Video notes. Today we're going to take a look at similar polygons, and our learning targets today will be to be able to find the length of sides of similar polygons. We're going to actually hold off on perimeters and area till tomorrow, which would be 8-1 day 2. Also, we're going to look to determine whether polygons are similar. So a few things about similar polygons. First of all, these are polygons with congruent corresponding angles and proportional corresponding sides. So if two things are similar to each other, they're in proportion to one another. They are the same shape, but they are different sizes. Corresponding side lengths will be proportional by a scale factor k. Another way of saying that is they are similar by a similarity ratio. Okay, so over here on the right hand side we got an example of triangle ABC being similar to DEF. It's written as triangle ABC with this little wave, that tilde sign, and then triangle DEF. This little tilde sign here represents the word similar, which means corresponding angles will be congruent and corresponding sides will be proportional. So we can say that angle A will be congruent to angle D, that's the first letter. E is going to be congruent to B, and then C is going to be congruent to F. Now their corresponding sides will be in proportion to each other. So notice here we've got side FD, DE, and EF. Those all come from the same triangle in the numerator part of our ratios, and then CA, AB, and BC, their corresponding sides are all in the denominator. Now when you put them all in ratios set equal to each other, this is called a proportion. They are all going to be proportional to each other, and they'll all equal the same similarity ratio or scale factor k. Let's take a look at a few examples and see how to apply this. In the diagram, we've got RST is similar to X, Y, Z. So R to S to T, X, Y, and Z. We want to find the scale factor. So what we're going to do is we are going to line up corresponding sides and reduce their ratio of sides. So RS is 20 and XY is 12. We're going to set that equal to the next one, ST, which is 30 over 18. And then we also have TR, which is 25 over 15. Now notice all of the sides from our first triangle, RST, are in the numerator, and all of the sides from the second triangle are in the denominator. You can also see that you have the largest sides are in one ratio, the next largest sides are in another ratio, and then the smallest sides are in another ratio. When we reduce all of these are all numbers in the top that are divisible by 5 and the bottom divisible by 4, so that's going to reduce down to, what is that, 5/4, right? I believe, and this is all divisible by 6 here, so this is going to reduce down to 5/4, and then the same thing here, 5, just kidding, that's not 5/4. We're going to reduce all of these here. That's 10, 6, and that reduces to 5/3. There we go. This one's going to reduce down to 5/3, and then yes, 5/3. So we got the right similarity ratio or scale factor. We want to list all the pairs of congruent angles. So here we got angle R is going to be congruent to angle X. Angle S is going to be congruent to angle Y. And then finally angle T is going to be congruent to angle Z. Finally, we want to write the ratios with the corresponding side lengths in the statement of proportionality. So what does this statement of proportionality mean? It simply means we are going to replace the letters of these ratios up here. So we're going to say RS, we're going to say RS over XY is equal to, and I'm going to get rid of this little extra here, it's not 3 letters, it's just 2 letters. RS over XY is going to be proportional to, and then we have ST over YZ, and then finally we've got TR is proportional to ZX. And these all came out to, remember, to reduce to 5/3. All right, and this is our statement of proportionality. In example 2, now we're given the diagram of triangle DEF. It's similar to MNP. So D to E to F is similar to MNP. We want to find the value of X. So sometimes we'll be given two similar figures with a missing measurement. And what we're going to do here is we're going to set up a proportion, two ratios that should be equal to each other, and we can find that missing piece. So we're going to take two sides that we know, such as ED over its corresponding side, NM, so 15 over 18, and we're going to set that equal to X, the long side here, EF, over its corresponding side, which would be NP 30. Now from here, we can reduce these fractions and then we can solve. So this one would be reduced to here. 3 will go into that 5, 6. And then we can just keep this here as X over 30. Now we're going to take our cross product when we solve a proportion. Remember, we multiply the extremes and the means here. So 5 times 30 is going to give me 150. This is equal to 6x. And now we'll divide off that 6, and x will have the value of 25. So there you have it. We solved for x here. The length of DF is 25. Now, had we chosen the other two pairs of sides here, 20 and 24, we still would have ended up with the same result of 25 for x. All right, moving on to example 3. I'm not sure why it says example 5. We've got example 3. Decide whether these polygons, ABCDE and KLQRP, are similar. And explain your reasoning. Now be careful here because it looks like the orientation on these is a little bit switched around. We got ABCDE going orientation this way, and then we have KLQRP going this way. So when we're matching up corresponding sides here, we want to make sure we're matching up the correct ones. So let's take and see if our sides are proportional. We've got 12 over 8 should be proportional to 9 over 6. And that should be proportional to 6 over 4. And that should be proportional to 9 over 6 again. And then finally, our last side here would be 12 over 8, which we already have. So really, we just need to make sure that these three ratios are all equal to each other. Now, if we reduce them down, here we'll have 6/4, and that would reduce down to 3/2. Which is equal to 9/6, which reduces to 3/2, which is the same as 6/4 reducing to 3/2. So, hey, we say yes, all of those corresponding sides are proportional. Sides are proportional. And the last thing that we need to do is just make sure our angles here, our corresponding angles are congruent. It looks like angle A is going to be congruent to angle K. That's all the angles that we know. But because our sides are proportional, we say yes, these two figures are going to be similar to each other. All right, let's take a look at example 4 now. We've got diagram triangle ABC is similar to ADE. So ABC, that top triangle here, is similar to ADE, that larger triangle. We want to find the scale factor. So in order to do that, we're going to match up two corresponding side lengths that we know. So let's find the similarity ratio, or the scale factor, by taking the ratio of that side that measures 12 over its corresponding side, which is 21. And we're going to reduce that now. 3 goes into both those. That's 4/7. So this is our similarity ratio, or also known as our scale factor. All right, now we want to find the value of x. Okay, so x is this little chunk right here, and it's part of that larger triangle AD. So once again, we're going to just write a proportion here, a ratio of corresponding sides. So I know in this smaller triangle up at the top, AB has a length of 10 over this entire side here, which goes from A to D, which is 10 plus x. So we're going to write that as 10 plus x. And then we're going to set that equal to their corresponding side. So in that smaller triangle, we've got this side BC, which is 12 over 21. All right, now we're going to take our cross product here. 10 times 21 gives us 210. And now we have 12 times this quantity, 10 plus x. So that's 12 times 10, which is 120, plus 12 times x, which is 12x. Next, we're going to subtract over our 120. All right, subtracting 120 from 210 gives us 90. 90 is equal to 12x. Now divide off that 12. 90 over 12, let's see here, x is going to have a value of, let me quick do my calculations here. Oh, what is that? 7 and some change, maybe 7.5. I don't know. Sure, let's go 7.5, 7.5. All right, so your value for x is 7.5. Next up, we want to find the measure of angle ABC. So from A down to B over to C. Well, keep in mind these triangles are similar to each other. All right, so triangle ABC, and that means their angles are going to be congruent. And then A to D to E. So this angle measure here in this corner, angle E, is going to be the same as this one right here, which is 32 degrees. So the three angles of a triangle add up to equal 180. These two that we have so far are 72 combined. So I'm going to take 180 and subtract 72, and that gives me 108 degrees is the measure of angle ABC. All right, for our final example, see what you can do to set that one up and solve for the value of x.